Oh, 5.1 that is messed up?
Yeah, the is messed up on 5.1.
Oh.
It's due like July 19th or something like that.
Oh, I didn't update the date. Okay, I'll have to fix that. All right, let's take a look at the point with the given. So what we're doing now is we want to get more into this polar coordinate stuff. So yeah, next time I'll bring you some polar paper. We're just getting started. We've only got 15 minutes, so next time I'll bring you some polar paper, which is this kind of paper that has the circles on it. Bring your 5 or 6 sheets of that with like 6 on each side, so you can do some of your homework more conveniently. So yeah, so basically polar paper has these circles that go out, these concentric circles. And it says identify the point. Well, how does it work? So basically this is a polar coordinate point. And so what that means is this is your R and this is your theta. And so now you know on the rectangular system, these are our last 2 topics. These are 5.3 and 5.4, and this class is over. Basically today, and when we come back on Monday, we're done with lecture. After that, I'm just doing review with you and tests. We'll basically review, take the 5th exam, review, take the final. That'll be all we have left after Monday. So we're basically right near the end. The last topic, both these sections, are about polar coordinates. How do you work in polar coordinates? So you think about rectangular first off. If I say find the point 2, 3 in the rectangular system, that means you go start at the origin, you go right 2, up 3. You know all about that very well. That's the system you've been working with for a long time. You go right 2, up 3, huh? That's the point 2, 3 in the rectangular system. We call it rectangular because you move like a rectangle, perfectly sideways, then perfectly up, right? This is almost like the edge of a rectangle, huh? So it's called the rectangular system. Starting from the origin, you move right or left, and then up or down, straight up and down, straight right and left. Okay, well now, in the polar world, in the polar system, when they give me something like 5, 45 degrees, you start at the origin again. And you, first off, I think of it like a cannon. You turn your cannon to aim at 45 degrees. Now, what do I mean 45? Let's do it like a circle here. 45 degrees is that way, huh? That's the 45-degree heading. So you aim your cannon at 45 degrees, and then you shoot your cannonball out a distance of 5. It's going to go 1, 2, 3, 4, 5 in the 45-degree direction. That's how you locate points in this system. This is the polar system, different than rectangular.
So the 45 isn't a reference angle?
It's the actual angle. Yeah, it's not just a reference. Good question, Kevin. Yeah, 45 is the actual. Like sometimes they'll give me, 317 degrees. Yeah, it's the actual angle. You turn your cannon to 45 degrees and shoot out 5 in that direction. See how I shot 5 in that direction and went 1, 2, 3, 4, 5. That's why I'll give you polar paper. Here, let's count. Just count the way 1, 2, 3, 4, 5. Right there, that's the point 5, 45 degrees. Aim the cannon, shoot in that direction.
That would be ravens, right?
Yeah, so 4, pi. So locate that point. Which one of those? So aim the cannon at pi. So it's funny. I think they should have done it in reverse order. Like I always start with the angle. I don't start with the number. I don't know why they did it that way, but whatever. Wasn't up to me. So pi radians. Where's that? That's back here. That's 180. So you aim the cannon this way, right? And you shoot how far in that direction? 4. 1, 2, 3, 4. Does that make sense? Aim at pi, shoot 4. Which one does that? Yeah, looks like A is doing that. See where the red dot is? It's where the cannonball falls. Good. Shall we go? So it says, aim the cannon at negative 2 pi over 3. Now, I would change that to degrees. I don't feel very comfortable with negative 2 pi over 3. So, you stick in for pi 180. You know that quite well. Use your calculator. You'll have your calculator on this stuff. And what is that? Negative, I think it's 120. Yeah, negative 120, okay. So if you think about, turn your, okay, here's, you're at the center. By the way, they call the center by a new name now. They call it not the north, not the south. Sorry, I'm just being goofy. It's coming up Christmas. It's the pole. It's the pole. They call the center now the pole. So it's a whole new thing. They don't, rather than the origin, they call it the pole. So from the pole, now aim your cannon, turn your cannon, rotate it to negative 120. This is 0 here, so negative angles go down, you know, huh? So this would be down 90, so down 120 is about that direction, isn't it? Negative 120 is about 30 degrees beyond 90. Does that make sense? That'd be a negative 120 heading. And then shoot in that direction. How far? Oh, negative 2. Yeah, now we're going to... Now, how? So you're tracking with me. The cannon is aiming this way. So we've taken the cannon, we've turned down 120 degrees. We're aiming the cannon that way. And then how far in that direction does the cannon fire? Negative 2. So what does that mean the cannon does? It backfires. Yeah, it backfires 1, 2. It's going to be like that. That's where the ball ends up. And the cannon operator is no longer with us. Right? Does that make sense what's happening there? So which one of those has a red dot? Yeah, in the upper right, B. Does that make sense? On that, so you turn to the angle, and negative angles are down, positive angles are up, negative angles are down. Turn down. You aim that way, but when the R is negative, it backfires. To work with for circular things. All right, try to find that spot. 1,0 degrees. 1,0 degrees. So take the cannon, aim it at 0 degrees. That's straight to the right, huh? 0 degrees. And where do we shoot? 1. To the right 1. Yeah, so you can hardly tell, but it looks like it's C. Yeah. Just 1 unit to the right.
And that's because the 0 isn't a reference angle this time,
right? Right, it never is. So with polar coordinates, this is always your actual angle. I'll try. Well, I got to get number 5 on the screen. Try number 5. Negative 3, comma, 3 pi over 2. So first find that angle. Put in a 180 for that pi. Put in a 180 there for that pi. So what's that? 2 into 180, 90. 3 times 90, 270. So that's negative 3, comma, 270. So turn the cannon to 270 degrees. And then backfire, huh? 3. So where's 270? Straight down. We good? Straight down. And then, so we're aiming the cannon. We're right here at the pole. We aim the cannon straight down 270 degrees. And then we backfire 3. 1, 2, 3. You good? This making sense? All right, now they're going to be tricky. So, plot the point and find other polar coordinates for which that's true. In other words, if you think about it, in this system, there's more than one way to say the same point. What am I talking about? Let me show you. What if I wanted to say straight right 3? 3 to the right. How could I say that in polar coordinates? I could say 3, comma, 0 degrees, right? Just aim your cannon at 0 degrees and shoot 3. But you could also say what? What if I aimed the cannon this way at 180? Negative 3, 180. Right? That's the same dot, isn't it? There's 2 different ways to say this same dot. You could aim at it and shoot 3, or aim the opposite way and shoot -3. Or, there's another way. Instead of 0, you could say 360. That's still just 0. And shoot 3. Or instead of 180, -3, add 360 to that. And that would be some big number. 540. 540, which is really the same as 180 with an extra rotation. Aiming that way, shooting it. Those are all the same dot, aren't they? You could just keep adding 360s. So that's what they're doing on this one. They say, okay, first off, which one of these is the point 5, 4 pi over 3? I don't know. What's 4 times pi over 3? 240? So 240, shoot out a distance 5. Which one looks like they aimed the cannon at 240 degrees? That's what 4 pi over 3 is. Yeah, is everybody good with C? See how that's almost 270? It's almost straight down 270. So it looks like 240. And they shot out a distance 5. Is that good? So C is the answer. Then they say now, okay, good, you got that. That's where our dot is. Now, we'd like you to say that same location 3 other ways. First, make the R positive, but make the angle negative. That's right, I didn't give you that option. You could say it by a negative angle. Instead of saying positive 240, you could say that same direction by a negative angle. Yeah, negative 120. Does everybody see that? That's the same direction. You can turn the cannon positive 240 or negative 120. You're headed in the same direction. So in other words, you can just subtract 360 from that. Right? We can always add or subtract 360s, huh? And you're still headed in the same direction. Because that's a full rotation, forward or backward. Right? So that's what we do. So, and that's what they want. See how they're saying negative here? I don't know if you can read that. They want theta to be between negative and 0. In other words, negative. So, but they want me to say that in radians, unfortunately. So it's negative 120. How do you change that to radians? Multiply by pi over 180. Do you remember that? Because that way the degrees cancel. So it's 12/18, negative 12/18 pi, divide by 6, negative 2/3 pi. So that would be 5, negative 2/3 pi. And that's just the first of 3.